Okay, so everybody across the board, if you can just look at the probability information packet, there's a whole video already on YouTube that goes through this a section at a time that you're all welcome to like find and go back and fill in as you see fit. But everybody needs to get pretty comfortable with a few different concepts, mostly the counting things, because in order to find probabilities, you have to know how to count all the different options. And a lot of times you can just count. Other times there's systematic ways of doing it. So let's quickly go through these examples. So if you read this quickly, you have 2 appetizers, 3 entrees, 2 desserts. You're picking one from each category. And the question is, how many different meals can you create? You probably did problems like this in the middle school. Do you guys remember what to do? Multiply. 2 times 3 times 2, so your total is going to be 12 different meals. And you could also do a tree. You guys were doing tree diagrams back in the day? Yeah. Where you would write like, let's say appetizer 1, appetizer 2, and then from there you got 1, 2, 3 entrees, 1, 2, 3 entrees, and then you got 2 desserts, 2 desserts, 2 desserts, 2 desserts, and you get what I'm doing. And then you can count. See what I'm saying? There's going to be 12 total in the end. Okay? So that should look familiar. But multiplying is the short way of doing it. Multiplying works pretty much for everything you have to do, especially when order matters. Okay? So if you're filling out your schedule for next year and you got 8 different classes that you got to fill in, right? I always like to explain it like this. So you have 8 slots to fill. And if you're looking for a first period class, you haven't picked a class yet. So how many classes do you have that you could fill in there? 8. Once you've taken care of class number 1, now how many do you have left for period 2? And so on, right? Now, if you've seen probability before, you probably know that you can write this not as this long expression, but there's something we call a factorial, the exclamation point. Okay? This is a shorter way of doing this. However, it might be faster for you on the calculator to just go 8 times 7 times. Do it that way rather than going through the menus and finding the exclamation point. But I will show you. So if you go to your calculator, if you press the math button, there's a whole probability menu in the math section, and you're going to be using 2, 3, and 4 probably for this meet. Okay? Seniors, you might even use, I think it's binomial. Well, actually, that might be in a different setting. But anyway, 2, 3, 4. So if I wanted to do 8 factorial, you would do 8, go to the math menu, hit the factorial button, and then it does it for you. Okay? Of course, like I said, if you just type buttons quickly, you can get there just as fast. Okay? Any questions so far? Okay. If you look at the next example, 61 albums that you have on your Spotify, and you have time to listen to 5, how many different orders can you make? Well, if we do the whole, fill in all the options as we go, what should it start with? 61, and then 60, 59, 58, 57. So that's probably the easiest way to figure it out. However, you should also learn that this is called a permutation. Anytime the order matters, that's called a permutation. Okay? And on the calculator, there's a way of doing this without writing them all out like this. It's this notation right here. N is the total. And then K is the number being selected. So if I wanted to figure this out using this notation in the calculator, n would be what? 61. And then how many are we selecting? 5. So it'd be 61p5. There's a formula for it that you can do by hand, but the calculator will do it for you. If you do the formula, you would fill in 61 factorial for the numerator, and then 61 minus 5 is 56 factorial. If you started writing all of these out, not that you have to do this, but do you guys see how a bunch of stuff's going to cancel out? From 56 on down is going to cancel, and this is exactly what's left. Okay, so that's where that formula comes from, this crazy formula over here. It is useful to know this formula, but again, a lot of times you can just do that. How many options do I have? It's faster if you do it that way. Okay? Any questions so far? Okay, the last counting thing before we start doing a contest. Actually, there's 2 more things, sorry. Let's do combinations. Combinations is where order doesn't matter. So maybe we're just interested in groupings, not necessarily in what order they're selected. For instance, if we have 18 students in a class and 6 are presenting, we would say there's 18 total and we're choosing 6. So you actually read that, 18 choose 6 to present. And the way you would fill it in is just like the permutations. You have 18 factorial. You still have this n minus k, so that's where the 12 factorial comes from. But because the order doesn't matter, we have to divide by this extra 6 factorial that accounts for all the extra counting that you would see. Like for example, if I picked 8 people in this room for this problem or whatever, if I started here with number 1 and went up, 1, 2, 3, 4, 5, that way, that's the same group of people, whether I start at the end and go this way or start at the beginning and go that way. Does that make sense? And so this 6 factorial is you dividing out all the repetitions that are really the same group. Now, if this problem were worded, we have 18 students in class, and 6 are going to be assigned specific roles, a group leader, note taker, spy, I don't know, all these different things that you can do in a class, right? Now it's not a combinations problem anymore, it's a permutations problem because they're assigned specific orders or specific spots to fill. Does that make sense? Okay. And by the way, you can, on the calculator, if you wanted to do 18, choose 6, you do 18, go to the menu, NCR, 6, and there you are, 18, 5, 6, 4. Okay. If you typed it in like this, yeah, make sure your denominator has parentheses around it. Okay. The last question. This is always one of my favorites because it's like a typical question and it's very easy, but sometimes it's easy to forget. So, how many letters are there in the word Mississippi? Is it 11? Okay. So, if we're shuffling all these letters up to create a new word called an anagram, does it make sense that there would be 11 factorial ways to do that? Because you'd have 11 choices for the first letter, 10 for the second, 9 for the third, and so on, right? The problem is that there's a lot of letters that repeat. So if this S were first, or the second S were first, it's technically the same anagram. Does that make sense? So it's kind of like this combinations problem where you want to divide out all the repetitions. So what you do is count. The first letter I see that repeats is the letter I. How many times do I see that? So you divide by 4 factorial, and that's because there's 4 I's. Anything else repeat? How many times? So divide by 4 factorial again to count, remove all those extra countings of the I's being in different spots. And then also I think P, that's it, right?
Yeah.
So divide by 2 factorial. Okay, so that would be how you type it in on the calculator. If you're horrible with parentheses, I just learned this last year. For a lot of you, if you press alpha and then y equals, you get this neat little menu that says numerator, denominator. What's that?
You're as bad as the kids.
I know. Well, I never knew that. I never had a need for it.
I did not know that one either.
Yeah, I knew that one. Do you guys know how to do that? Have you seen that before?
No, probably.
Okay, so some of them are like, whoa, I didn't know you can do that. Because I heard somebody say, oh, you need parentheses, right? Guess what? If you use the fraction template, which again, you press alpha, y equals, first option is the fraction template.
And that second option is improper, is a mixed number. If you want to do mixed number.
Oh, cool. I did not know that. Anyway, you could type it in exactly the way you see it. 11 factorial divided by 4 factorial, 4 factorial, and then 2 factorial. So if you type it in exactly the way you see it on paper, let's see, can you focus on the calculator? Like that, it will do it for you. Without having to worry about, oh, do I need parentheses or do I need extra? Okay. Okay. So that's kind of the background for counting. Now I'm going to cruise through some contests. So freshmen, I'm going to go through your contests first. Everyone else should follow along in the packet because these are basic questions that you should all be able to answer. Okay. So if you could just take a minute, less actually, read question number 1. And we actually did something like this in the notes. How do I figure this out? Which is piece of cake. Freshmen are like, oh, this is great. This is going to be an easy contest, right? All right. And so everything else that comes up, I'm just going to kind of explain it as I would do it, trying not to like necessarily go to a formula, but just kind of how I remember things. Okay? So here we got 10 balls, 6 red, 4 blue. 2 balls are drawn, one after the other, without replacement. So that means if I pick a ball, now there's how many left? 9. I don't like put it back. Does that make sense? So you take one out, now there's 9 left. Question is, what is the probability that they are of the same color? So before you start figuring it out, here's what I would do. I would try to figure out how to succeed. So if I draw a red, what would I have to draw the second time?
Red.
So I like to write it like this. Probability of red and then red. Or blue and blue. Does that make sense so far? Okay. For your intents and purposes, and means multiply. Like 99% of the time. Sometimes you have to divide something out, but and means multiply. So if I say probability of red on the first draw and red on the second draw, you got to multiply 2 probabilities here. Does that make sense? You got to multiply 2 probabilities there. What word did I link these with? It's this option or that option. Whenever you see the word or, that translates to addition. Okay? So, what is the probability that I pick a red ball on the first try? That one red ball is now gone. So, what is the probability that on the second draw I pick a red ball? Make sense? Plus, and now we do the same with blue. So this will be 4 out of 10, 3 out of 9, help me out. Plus 30 over 90, 12 over 90, 42 over 90 reduces. You guys know how to reduce fractions in the calculator, right?
Yeah. You want us to do that?
Does anybody not know? So it was 30 over 90 plus 12 over 90, right? You get that. On math team, if you wrote 0.47, that's wrong. If you wrote 0.467, that's wrong. If you wrote 0.46 with a line on top of the 6, I think they'll count that because that's technically exact. What we want you guys to do is press math, frac, and it will reduce it for you. I still hear a couple people like, what? Yes. So make sure that you're always reducing your fractions. Okay? You guys do 3 real quick. You should be able to do it based on what we've talked about. Everybody. And juniors and seniors, or seniors especially, if this is going a little long, we can just pick up where we leave off tomorrow. I don't want to keep you here longer than 4:30. But it's not hurting you to like see the freshman stuff, the sophomore stuff, and so here's how I'm thinking of setting it up. I mean, they pretty much spell it out for you. 3 heads in a row, or, so that means add, 3 tails in a row, right? What's the probability of getting heads? 1/2 each time, right? So it's technically 1/2 cubed, and the probability for tails is identical. So it's 1/8 plus 1/8, which is 2/8, which is 1/4. Does that make sense to everybody? Freshmen, how are we doing? Make sense? Okay, I know some of the older kids are cruising, but try number 4. 5 I'll explain, but 4 I think you guys can figure out.
Because there's 2 repeating. Oh wait, this is where? Wait, what is 2? I got the number.
What is the answer?
2,520.
2,520.
Yes.
Good.
I got it.
7 factorial divided by 2 factorial, right? Okay. Why are we dividing by 2 factorial? There's 2 C's that are, you can flip-flop, so you got to divide by 2 factorial to count out all the extra times that we counted. All right, here's a new tip, because we haven't talked about this. It's in the notes, but a lot of times when you see these words right here, at least, means that there could also be a different way of doing it instead of how they're asking you to do it. Okay? In fact, I don't really see a way of doing this otherwise, because if it's saying you got 52 cards and you draw until you get a heart, right? And they ask you, what's the probability that you get a heart and it takes you at least 4 times? Well, if you start breaking it down, that means at least 4 translates to on the 4th time I get a heart, Or on the 5th time I get a heart, right? Do you guys see where I'm going with this? This extends infinitely. So there's really no way to do it directly where you do, 4 plus 5 plus. You can't do it because there's you could be here forever.
But it doesn't end at 52. Like you only have 52 times.
No, because you keep putting it back in the
Oh,
deck.
Right.
So it does not, you can't do it that way.
It's not like you leave it out.
So whenever you see these words, at least, okay, usually that means that we can do 1 minus the probability of the opposite thing happening. We call this a complement, by the way. If you guys did set theory, you probably saw that last meet, right? Complement.
Oh, yeah.
Okay. So what is the opposite of drawing it and then taking you at least 4 times? It takes, is 0 even an option? Not in this case. Okay, so we could either get it the first time, the second time, or the third time, and that would be the other options. Does that make sense? So if we do 1 minus the probability that it's on the first, second, or third time, that's 1 minus the probability of the first time. These are all connected with the word or, plus the probability that it's the second time that we get a heart, plus the probability that it's the third time that we get a heart. So let's just start filling this in. What is the probability that on the first draw, I pick a heart? 1 out of 4, or 13 out of 52, but let's reduce it, right? So 1/4. Plus, let's go on to this one. If I'm drawing a second time, what does that mean happened on the first draw? I didn't get a heart, right? So this is not a heart. How often, or what's the probability for that? 3/4. But then on the second draw, you get a heart. Do you guys see where I'm getting those fractions from? Okay, so that takes care of drawing a heart the first time, drawing a heart the second time. If I have this last case where I draw a heart the third time, I'm going to run out of space, so I'm just going to squeeze it in here. That means that the first time and the second time, I did not get a heart. So what's the probability for both of those? 3/4 times 3/4. And now the third time is where I get the heart. So that's 1/4. So you figure all that out. If you guys can do that, that would be great. This is all in a parentheses. So add these 3 probabilities together, subtract it from 1 since it's really the opposite of what we want, and you should be in good shape. What are we getting?
Where did you get like your fractions?
3/4 is like 3/4 is the probability that you didn't do it the first time, right?
Are you sure?
So and then the third time it's 2 of them because like you didn't do it the first time.
Exactly.
Yeah, I can't believe it.
Did it answer your question?
Yeah.
Okay.
Oh, gosh. I don't know.
0 minus.
That's what I'm getting. One fourth plus 3/16 plus 9/64. Subtract it from 1. Because remember, what we just found is the opposite of what I wanted to find. So you got to take it away from 1.
Oh, man.
Okay. We good?
Do you know where I can get like a calculator for?
Ms. Rodriguez, who just ran out.
I can't do that. Oh, is it?
Okay.
Oh, no,
Sophomores. So freshmen, you guys are free to stay, or if you want to try to compete at the sophomore level as well, we're going to go through some of this stuff now. Okay.
I think one of our now.
I'll post this video so that you can watch it later for the sophomores. Okay. So sophomores, you guys have geometric probability, which is essentially what we've been doing. The only thing is that usually there's lengths, areas, or maybe even volumes involved. Okay? So number one, we have two real numbers. One number is between 0 and 2. The other one is between 0 and 3. What is the probability that the sum of the two numbers chosen is less than or equal to 5? That is a trick question. It's 1. Why? If 2 is your maximum and 3 is your maximum, no matter what you pick, you're always going to be 5 or less. Does that make sense?
Oh, because 2 plus 3.
Yes. So here we have a length of 2, here we have a length of 3. That's our feasible region. So it's 5 out of 5 because 5 is also the feasible region.
So isn't it 100%?
Yeah, what the answer
What's it,
was?
just 1? It's 1.
Would they make it wrong?
Unless they ask for a percent, I would never give a percent.
They said probability.
Right, and usually that's a ratio. Probability is defined as number of successes divided by the total. And so since all 5 units of length is a success, it's 5 over 5, which is 1. Okay, number 2. Piece of string, 25 inches long. What is the probability that one piece of string is at least 5 inches longer than the other piece of string? Well, at most 10, that's correct. And the other one has to be at least 15. Very good. So the only part that doesn't work is between 10 and 15. As long as we pick over here, we're guaranteed that this is at least 5 more than the other section. Or vice versa over on this side.
You said it's only cut one time.
Right.
Yeah. One string.
But you could cut it from this end or this end.
If you cut it anywhere from here to here or here to here, that guarantees that one side is at least double or 5 more than the other one.
Yeah, but there's no space between 10 and 15.
This represents the area or the length where you cannot cut the string. Because if you cut in here, let's say you cut at 11. This is 11, and now the other length is 14. That's not 5 more than, you see what I'm saying? So this shaded length represents all the possibilities of where to cut. So how long is that? The yeses. 20 out of a total of 25. So 4/5 is the probability for that. Mm-hmm.
That makes sense.
That's a yes, that's not a no.
Yes. Okay. Number 3, read that real quick, and then I'll walk you through what I did. Mm-hmm. So this is just a basic area question. You guys see that?
Yeah.
We want to find the area of the black. That's where we want to be, divided by the total area of this figure. How long was the square? Or what's the length?
9 by 9.
9 by 9. And these are trisected, so that means each one of these is 3 in length, right? The total area is 9 by 9, which is 81. And now we just got to find the area of the black cross. So now what I did, I kind of actually found the area of the white and then subtracted that from the total. And so what I'm seeing is here, for instance, these two sections, what shape does that make if I put it together? This is just a 3 by 3 square. If I put these together, right? So that's going to make 9. Do you guys see how I can do that in the other corners? This triangle put together with this triangle is another square that's 3 by 3. So far I have 9. Okay, and now this little triangle, this is interesting. So there's, at least I had to think about it like this. I'm going to zoom in. This is a 90-degree angle, and this is 3. How long are the two legs if this is 45, 45, 90?
Oh my god, you guys have it on the board. Special triangles,
Oh, wait.
divided by root 2.
3 over root 2.
Yeah, that's what I got.
So that means we have 4 triangles that have this length and this width. So that's going to be 1/2 times 3 over root 2 times 3 over root 2. And we got to multiply that by 4. That's going to be 9 over 4 times 4 is 9. And so now I have another 9 for a grand total of 27. So 27 units is all the white stuff. That means the area that I want is 54. So whatever 54 over 81 is, if you reduce that, I think that's 2/3. Any questions so far? Yes.
You can also just combine the 4 small terms into one square.
Ah,
And then it's just
amazing. See, I didn't even think to do that. If I put all 4 of them together, that's another 3 by 3 square. Very good, yes. And I could have avoided that whole 3
That
over
is
root
good
2.
practice, because this stuff comes up actually more often.
Good, yeah, and you're the sophomore coach, so you would know more. Okay, well, I'm glad I did it the hard way. All right, read number 4. Okay. This one's interesting. I thought for me this is the hardest one. Of course you would, geometry teacher. So we have a circle with the radius of 5 inches, right? And then there's a circle within the circle that has a radius of 2. And now there's if I remember correctly, a little yellow disc. Oh, I actually have yellow. We'll use yellow. And this little white or this little yellow disc has a radius of 1, and this gets placed, and we want it to be in the donut that's out here. Does that make sense? Entirely. Does that make sense? So if the center of that circle is a little too far, then that's not going to, part of it's going to be into that, I guess that's supposed to be red, inside the red. We don't want it to be in there. Okay? So if you imagine the center of the circle at what length is this center here?
3.
And if I put it on the edge, at what length is that?
4.
So anywhere between 3 and 4 guarantees, no matter where I am, right, that we're going to be inside the entire in the white ring. Does that make sense? And so now if you actually map it out, you get another circle and another one. And so this is what we're trying to find, this area. So now the question is, what's the radius of the outer circle? So the outer blue circle. From center out is 4. Does that make sense?
Yeah.
And now what's the radius of the inner blue circle? 3. So if I take this area, which would be pi r squared, so 16 pi, and subtract out the area of the smaller blue circle, which is 9 pi, subtract, you get 7 pi for the feasible region. And that's out of a total of 25 pi for a fraction of 7 over 25. That is a good problem. Okay. Last one. And see, this is much more my favorite because it's all algebra. Just draw a picture, find an equation. So just take 30 seconds and read it, and then I will explain how I thought about it. And maybe if you want to add anything to Soul, because I don't know if the approach is necessarily the best one, but. And juniors, we might be able to get through most of yours. Yours is actually quicker to do than the soft. The sophomore one takes a while to explain. Okay, so the way I thought about number 5, I actually drew a coordinate plane, like an XY axis. And I let X equal Tom's mileage. And Y was, who's the other person? Sue. Sue's mileage. And there's 23 miles per gallon, 16-gallon tank. Multiply those together. That means that a full tank gets you 368. But we want to, we're looking at it being a half tank, right? So what's that? If I cut that in half, 184. So combined, they cannot drive. It has to be less than 184 miles. Does that make sense so far?
Yeah.
So if I say that in an equation, Tom's miles combined with Sue's mileage has to be less than or equal to 184. You guys with me? And so if I draw that, here is 184 on the y-axis, here is 184 on the x-axis, that is this line. Oh, you know what? I switched that. My bad.
Yeah, that's right.
This should be greater or equal to, because we want to, that's the part that tricked me the first time, and I did it again. We want the tank to be less than half full, which means we must have drove more than 184 miles. Does that make sense? Okay. So we want to be above this line. You guys see that? So we want to be above this line. Now, at most, what did Sue drive?
200.
So at most, Sue drove 200 miles, and at most, Tom drove 150. And so you actually get the feasible region is this trapezoid right here. I'm sorry, this is the success region. The feasible region is this entire rectangle from 0 to 150 for Tom and from 0 to 200 for Sue. So the total area, so total feasible area is 150 by 200, which is 30,000. And so that's going to be my denominator. And now my success area, the gold, we just have to find the area of that trapezoid. Do you guys remember the area formula for a trapezoid? Good. Well, base 1 is right here, and base 2 is right there, because the bases have to be parallel, right? So how long is this tiny little base? 16. How long is this one? Well, this here is 34, right? So how long is this up here? 166. And so it's 16 plus 166 over 2. And now the height is 150. I'm looking at it sideways. And so I don't know what that is, but you're going to take that and divide it by 30,000 and then reduce your fraction. That sounds right. 91 out of 200. Anybody have this total up here?
Yeah, it was 13,650.
Okay. So after you find the area of the trapezoid, you get 13,650 divided by the total, 91 out of 200. Make sense? Okay. This is what I would say as a sophomore contest. This is probably a moderate difficulty because these last couple of questions were tough. But I've seen ones that have volumes where you have to like visualize slicing through a cube and like removing volumes and stuff to figure it out, which is kind of cool. Is this how you would have done it?
Yes.
Okay. So sophomores, you guys are good. So as long as you understand mostly the sophomore contest, and if you have a little bit of knowledge of freshman stuff, that ain't gonna hurt. Juniors, let's get through as much as we can.
Yes.
It is. It's areas, volumes, and yes. Tomorrow. Tomorrow's a regular practice, yes. Unless the seniors that weren't here are here, I'll probably just pull them aside. No, juniors, we're going to cruise through as much as we can. Your contest is actually quicker to get through than the sophomore. Okay. Did you guys read number 1 and try it real quick?
There's 14 and 13 and one of them lines up with itself. So it's 13 plus 4 minus 1 over the...
So I'm going to take what you said and write out a formula, but you're right. It's the probability of drawing a diamond plus the probability of drawing a king. And then you guys at the juniors, the part that's different from the freshmen is you might have to subtract out like any double counting. It's probability, I should write this formula down. Probability of A or B is the probability of A plus probability of B minus the probability of A and B. This is not always present, but if there is such a thing as event A and event B occurring together, then you would subtract it out because you would have counted it in both the first fraction and the second fraction, which is what you just said, Anthony, right? So how many diamonds are there?
13.
And how many kings? And is there a diamond and a king card together? One of those. And so that one card got counted twice in both of these, which is why we're subtracting it out. So really it's a total of 16 out of 52, which reduces to 4/13. Make sense? See, look at us cruising. We would have spent more time on the sophomore number 1. Okay. Number 2. So there's formulas for conditional probability, but for juniors, most of the time, if you just organize the information into a table, sometimes they'll give you a table, but if you organize it into a table, you'll be able to figure it out without having to worry about a formula. Okay, so here's what I did. So we have juniors and seniors. And we have males and females. And it says 250 of the 400 seniors are girls. So 250 females. How many males? 150. Right. So I'm just kind of filling in all the details. Oh, I went to the second bit of information. Maybe that's why you were confused. 300 juniors are female, which leave us with 200 male, because there was a total of 500, right? So this is all the details they give me. Let's see if we can answer this. If the name is that of a girl, what is the probability that she is a senior? So how would I find that?
250 over
Which total?
The total number.
It's not the whole total.
Junior number.
It's
Oh.
just females. Because look at what they told you right here. If the name is that of a girl, so we're only focusing on the girl column. So how many total girls are there? 550. How many of those were juniors? Well, that's 250. And so if you reduce that, it's 5 out of 11.
Wait, aren't there 300 junior females?
Yes.
Yeah, I'm confused.
They're looking for a seat.
Senior.
Oh, okay. I think you said. Oh, okay, sorry. Okay, sorry.
Does that make sense?
Yeah.
Yeah, I kind of switched the order a little bit. Okay. 3. Hey, guess what? We did this already in the freshman level. Let's see if you guys could figure this one out. I'll give you a minute.
Oh no. It's okay.
I thought he was getting excited over there because he knew what to do.
He knows exactly what to do. He knew.
Is this how you guys are thinking about it? We want them to be the same color. There's 3 ways to do that, right? Both red, both white, or both blue. Or. So add. But we want red and red, so multiply those together. How many red are in the first spinner? 1 out of 3 sections. And the second one, it's 1 out of 5 for the second spinner, right? Same story with white.
It's not thinking about your boyfriend chocolate.
Blue, 1/3 for the first one, and now it changes. There's 3 blue for the second spinner.
Yes, we did.
And so what should you get?
Good job. 1/3.
1/3, yes.
How do you think?
I'm going to actually explain 5 because that's actually quicker to get through. If we have time to do 4, I'll at least talk about it. It's actually, they're both pretty straightforward, but 5 is easier to explain. Okay. So you're drawing cards, and we're interested in drawing 2 spades. And we want to know the probability that the second spade is drawn exactly on the 6th draw. Okay? So if I start writing out the possibilities, I'm going to use S for spade and N for not a spade. One way to do that would be I draw a spade the first draw, And then what needs to happen on the second one?
No spade.
No spade. And then on the third one?
No spade.
No spade all the way until I get to the
Six.
sixth one. 1, 2, 3, 4, 5. So then my sixth one would have to be a spade. So that's one way to do it. Does that make sense? Plus, and see, the beauty of this is we're not going to have to write all this out. I'm just basically going to take this S and just shuffle it through. Do you guys see what I'm talking about?
Yeah.
So how many ways are there going to be?
6, 25.
That is correct. Whoops, that should be N, and then S, and then N, S. Do you guys see what I'm talking about? The second spade must be the sixth time. The first spade could be the first, second, third, fourth, or fifth time. So there's 5 ways to do that. Okay? So instead of actually writing it all out, since there's 5 ways to do it, all these probabilities are going to be the same each time. Does that make sense? What's the probability that we get a spade? 1 out of 4. How many times do I need it? Total. Twice. Does that make sense that we're going to have a 1/4 in there? Twice. And I need to fail. I need to fail how many times? 4 times. And what is the probability of failing or not getting a spade? And so that is a short way of figuring that out.
What is that problem?
I can already see who my contestants and alternates are going to be. Can you?
Yeah, we can cover all.
There's 5 that are like focused and determined, and 2 that are.
Yeah, but we get the highest.
That could change. You never know.
100% here, so maybe
What are we getting?
they can keep
25.
Maybe I just didn't reduce mine.
Did you know 2 points?
Definitely not getting that.
I did 3
Counts 0.7. Oh, I put it to the wrong power. Okay, yeah, remember. It's 405 over 406.
Oh my gosh, Tony, smart minds think alike.
There we go.
Right.
Okay.
Hey, everyone.
All right. Juniors, it's been a long day. Lock in for 3 minutes and we can get 4 done. Okay? Here we go. I'm going to explain the problem real quick.
Probability item.
So we have, what are their names?
Drew.
Flossie and Drew.
do the fun.
Yeah.
Oh, but we don't care about Drew. It's Flossie versus Ned. Flossie currently has 15 points. Ned currently has 19. If a club is drawn, then Flossie gets 3 points. If a non-club gets drawn, then Ned gets 1 point added to his total. The game ends at whenever somebody reaches 21 points. So that's basically what that word problem is telling you. They want to know what the probability is that Flossie wins. So the solutions actually do every single output or outcome. I'm just going to focus on the ones that get us to a victory for Flossie. Okay? So let's start with the easiest one. If a club is drawn, what's the new score? 18 to 19. And now how often, what's the probability of drawing a club? 1/4. Okay? Next, if I draw a club again with a 1/4 probability, what's the final score?
21.
21 to 19. So that's one path to victory. Does that make sense? Is it possible for Ned to win the next one and then Flossie to still win in the end? So if Ned wins the next draw, that happens 3/4 of the time. right? And now what's the score? 15, 20. Can Ned win again?
Yeah. I mean,
No, because then Flossie doesn't win, right? So in order for Flossie to win, now she's got to win. And so now the score would be 18 to 20, and that happens 1/4 of the time. And she would have to win again to finish at a score of 21-20. And that happens 1/4 of the time. There's one more path. Where else could Ned win? Up here, after Flossie wins one time, Ned could win. So now it's 18 to 20 again. And that would happen 3/4 of the time. But then Flossie would have to win the last time, and that would happen 1/4 of the time. So if you follow all these paths, the first path is 1/4 times 1/4. Do you guys see how I'm getting that? The second path is the zigzag that I drew. 1/4 times 3/4 times 1/4. So from here to there to there. And then the last path is 3/4, 1/4, 1/4. Multiply all those together and add them up, and you get your probability, which is 405. Oh, wrong problem. 5 out of 32. This is for number 4. Okay? All right.